Today, I want to demonstrate configuring SQL Net, or Oracle Net if you prefer, to run over TCPS. This can be a bit of a nightmare to get going, but the method I'll show you is simple and it works. Whether it's adequate for your site is a question I can't answer, but it's certainly good enough for many. Nowadays, virtually all sites require encryption of data in transit. My preference for this is always to use SQL Net native encryption. Why? Because it's very easy to set up, is usually adequate, and requires no client-side configuration at all. However, some sites have a blanket policy that you must use TLS, or SSL, to use the older term. And if that applies to you, that you have to use TLS, then there's no choice. You have to do it. In that case, my advice is keep it simple. If at all possible, use self-signed certificates that will last forever and store them in an Oracle wallet. In a typical environment, your end users will be connecting to an application server over HTTPS. For that layer, you will need a real certificate issued by one of the trusted authorities, and your browsers will have to be configured to accept that certificate. This is a nuisance to manage. You might, for instance, buy a certificate from VeriSign or DigiCert, one of the other issuers, and then you'll maybe have to renew it every few years. Or you can get a free certificate from Let's Encrypt, but that you'll have to renew every 2 or 3 months. For the SQL Net traffic between application server and database, if you wish, you can go to the trouble of using real certificates. But I would use self-signed certificates if at all possible. They will usually be acceptable. The traffic is on your own private network. Why would you need anything more? So, let's do it. The first step is to create wallets and certificates for the client and the server. I'll do the server first. I'm running off this Oracle home here. I'll create a directory that's going to store the wallet, TMP TLS server wallet, and then create the wallet itself with the Aura PKI utility. Aura PKI wallet create, location of the wallet, password, and auto login, of course. We don't want to have to be supplying passwords all the time. Then I need to generate the certificate and the keys. Aura PKI wallet add. And I'm going to add a certificate for common name JWLAT. That's just the name of my PC. It's self-signed and it will be valid for 10 years. And export the trusted certificate that issued the self-signed certificate with export. And this file is what I'm going to have to transfer to the client side. So what do we have? In the wallet directory, we've got the certificate, the wallet itself. We've got the auto login version, and there's the exported trusted certificate. Repeat the process for the client side. I'm working on the same PC, but it is a different Oracle home. Create a directory, TMP TLS client wallet. Create a wallet in that directory. Again, of course, auto login. Generate a self-signed certificate for the client. Again, same validity, but the common name, JW client. And export the trusted certificate that issued the client certificate. Now I need to load the server's trusted certificate into the client wallet. Aura PKI wallet add -wallet the client wallet, provide the password, and I'm loading up a trusted certificate, which is the server-side trusted certificate. And if we see what we've got with the wallet display command, my client-side wallet has its own user certificate, and it's got the trusted certificates from both client and server. Then on the server side, I need to load the client's trusted certificate. So I add to the server wallet the trusted certificate from the client, that it will then trust the certificate from the other side. And if we look at what it has, in its wallet now, we have the server's own certificate and both the trusted certificates. The second step is to configure the server side to listen for TCPS and to make use of the wallet. So first off, I need to adjust the listener.aura. I need to add these directives. Version of SSL, we're not going to use client authentication, and most importantly, where the server's wallet actually is. And I also need to add a listening address to the address list here. So I'm going to have it listen for TCPS on port 2484. File, save. And if I then bounce, before I do that, there's one more file I'll need to edit. I'll also need to edit the SQL Net.aura file. By adding similar directives. Authentication services, we're going to enable TCPS. If you were using native encryption, you would not want to use native encryption on top of TCPS connections. But again, the location of the wallet. File, save. And now bounce the listener. Stop the service. Oops, that's not quite right. That's the name of the service. Stop the service. Goes down and then start it up again. And there we see it's listening for TCP on port 1521 and TCPS on 2484. Then we need to configure the client side, a TNS connect string, and tell it where its wallet is. So beginning with TNS names, we'll give it another entry. So I've got ORCLZ says use TCP to connect to service ORCLZ. ORCLZ TLS goes to the same service, but over TCPS. And then we need to edit its SQL Net.aura file. And for SQL Net.aura, tell it where the client wallet is, and a few other directives. So, having completed the configuration, let's test. First, just with TNS ping or CLZ TLS. That looks good. Does it actually work? SQL plus Scott Tiger at that alias. Well, I'm logged on. What protocol am I using? Select syscontext, user env, network protocol from Dual. And what do you know? I'm connected over TCPS. To conclude, when it comes to security, there's no right or wrong. There is only compliance with the standards for your environment. My advice then is, if at all possible, keep it simple, as in the method I've demonstrated. There are many other ways to do it, all sorts of variations, but the method I've demonstrated works. If it isn't good enough for you, well, at least it will still be a good starting point.
If you liked this video, please like it and subscribe to our channel.